Thanks, Valeria, for the introduction. Well, in case you were wondering, yes, this is the first time I gave a talk with being almost the only person in the room. So bear with me and let's see how it goes. So the topic of today's talk will be an introduction to the MATLAB computing environment. There are many different ways one can tackle a talk like this. For today's talk, I made the call of giving a little more attention to people with little to no computer science background, so to give them a way to start familiarizing with this platform. But I hope everyone will be able to take something out of this webinar, so no matter your starting level. Okay, so this is the overall outline of today's talk, but we're going to cover a lot of topics. So without further ado, let's just go ahead and clarify what we are talking about when we say the word MATLAB. So the name MATLAB comes actually from the full name of Matrix Laboratory. That's because the basic data structure in MATLAB are actually matrices, and everything in there is built around the idea of simplifying as much as possible matrix vector operations. Mathworks, which is the company behind MATLAB, has built an entire framework around this idea. And this framework comprises an high-level scripting language, an interactive computing environment, and a perfectly tailored graphic user interface, together with an ever-growing number of toolboxes that are designed to make of MATLAB possibly one of the easiest options when it comes to automating complex processing pipelines, visually exploring dataset, or prototyping algorithm, or developing new models. But more than what, the real question is probably why. Why should you start learning and using MATLAB? How does MATLAB compare with other options that are out there and that you can use? So the fact that MATLAB is a scripting language more than an actual proper programming language make it a bit hard to compare it with low-level general purpose compiled languages like maybe C or C++ or Fortran. MATLAB, in fact, is not designed with fast execution and high performance in mind, or to actually build application from the ground up, like, for example, C++. But on its side, MATLAB combines a set of really powerful tools with it being much easier to learn for people with really minimum computer science expertise. It achieved this goal by offering a full package of professionally developed tools and applications that are developed by the company behind MATLAB itself, and that sometimes you can also use without needing to write a single line of code. This clearly comes with the slight downside that MATLAB is a commercial product, and actually it's also a rather expensive one. The comparison between MATLAB and Python instead is a little bit easier. In fact, while Python is still an actual true general purpose programming language, it shares with MATLAB a few more similarities, like the possibility to be treated as a scripting language and an overall easier portability, because both MATLAB and Python are interpreted languages. And generally, both are a more relaxed syntax, especially if we compare them with C++ or C. The roles kind of flip when we compare MATLAB with a language like R. In this case, it is R that is the more specific one, a more like kind of a niche language, mostly focused on data analysis and statistics, while MATLAB offers also a wider range of tools. It is still pretty good option if you want to tackle statistical or machine learning problems, but it also have a much wider range of applications. And MATLAB is also faster than R, and this is not something that MATLAB being faster that happens really often when we talk about MATLAB, so I thought it was worth mentioning it as well. Okay, so there would have been much more to say about how MATLAB compares with other options, but let's just sum it up saying that, as usual, is more of a matter of pros and cons. MATLAB is really easy to approach. It has an entire company behind it focused on providing the user with the best experience, no matter the level of knowledge about programming and coding. But we have literally to pay a price for that, because it is a commercial product and it requires a license. It requires you to buy a license in order to use it. This is clearly something that we always have to keep in mind. Good. Let's just say that we do have this license, and we just want to know how we can actually start using MATLAB. So in the next section, we are going to focus on the very, very basic concept of MATLAB as a programming language, so that hopefully you will be able to read, understand, and try to write some simple code in MATLAB. Okay, so when you fire up your MATLAB executable, no matter if you're on Windows, macOS, or Linux, this nice graphic user interface pops up, and it gives you everything you need to get started writing some code and running scripts. The main element here is the command window. It may look little bit like a Unix terminal, but it is actually closer if you're familiar with it with the Python console. In the command window, you can write any kind of command using MATLAB's own language, and as soon as you press enter, this command that you write will be immediately executed. On the bottom right, down here, you have the command history, where every command you typed previously in the command window is stored. In this way, you can backtrack everything you did. I never actually checked properly, but my fair guess is that it is able to store a few weeks or even months maybe of history, so you're pretty good from this point of view. Right above the command history, you have the workspace. That's a matter of personal taste, but I think it's one of the best features of MATLAB user interface, because there you will always see a list of every variable you define by running your code, so that in every moment you can be aware of what names are already taken, what variables you can call and interact with in the command window, the size and shape of matrices and array, and so on. On the left side, you have the file explorer, which shows us the folder we are in and everything that's inside of it. This is important because this is the way we can decide, we can set the working directory, which is the directory in which our code will be executed. And because if in our code we need to read some files or access some function, we need to know where we are and if we can see and access it or not. Last thing, on the top, you will find the toolbar menu, which reflects the style of the ribbon menu of the Office suite somehow. Using commands is as simple as clicking buttons, and in this menu you can perform most of the operations related to writing and running MATLAB scripts, but we will see a little more going on. Okay, the first really good thing about MATLAB being a commercial product is that commercial products are usually really, really good when it comes to writing quality documentation. There are many ways you can ask for help in MATLAB, and the two most common ones are typing help or doc, followed by the name of the function you want to know more about. If you use help, you will get a short summary of the main properties of a function, of the function you're curious about, and this will be printed directly into the command window. If instead you use doc, you will fire up the actual documentation interface, where you can find a really in-depth description of everything you can do with a certain function, together with example of usage and a lot of theory, and sometimes also implementation details. So I really suggest you to try to use it as much as possible, because it is also a good place to actually study some theory. Okay, after learning how to ask for help, the second most important thing is to remember that MATLAB, the name MATLAB stands for Matrix Laboratory. So knowing how to define matrices and vectors, arrays, is key to work with MATLAB. Something that makes MATLAB way easier than most programming languages is that we don't really need to be too much detailed when we create a variable. For example, we don't need to specify the type or allocate memory for it. We just need to choose a name, like S in this case, and set a value. If we just set one value, it means our variable is a scalar. Usually the default type is double, but you can change it if you want. If you use more than one value, it means that it's an array of whatever dimension you want. If you want to create a vector, which is basically a one-dimensional array, you can just use square brackets like this and list all the elements of the array within this bracket. If you use commas to separate the values in the array, you will get a row vector. So one column, a 1 by 3 vector, arrow 1. If instead of commas, you use semicolons, you will get a 3 by 1 column vector. So this is a little convention you need to be aware about. I think it's probably, it may be easier to grasp the difference if we look how we can define this 3 by 3 matrix here. You can see that we are using commas to separate elements on the same row. So 1, 2, 3 are elements on the first row, and then semicolons to separate rows in the matrix. So that's pretty simple. Other interesting character it is important to keep in mind while writing code in MATLAB is the percentage sign that is used to write inline comments, and the semicolon at the end of each statement, of each instruction, which line of code. If you skip the semicolon at the end of each line, what happens is that after each instruction is executed, you will get the output directly printed on the interactive console. Most of the time, you don't want that. First, because it may be annoying, but also because printing to console slows down your code significantly. So fair suggestion is don't forget the semicolon at the end of each line, but we will remind you about that. We'll get to it later. Okay, once we know how to create an array, we may want to be able to access element inside of it. This action is usually called indexing or slicing. And to do that in MATLAB, it's important to keep in mind that indexing here starts from index number 1 and not 0, as usual for many other languages. For instance, let's say we have this big matrix A, and we want to access the element 3, 2. We will use this syntax here with parentheses. And if we run this command, we will get the element, the value 76 printed out on the console. This is actually the element of the third row, second column of the matrix. This is because indexing starts from 1. So we get row number 1, 2, 3, and column 1, 2. So element in third row, second column. If instead we want to extract the entire first column, select the entire first column of this matrix, this is as simple as using a column. Column in the first position here in the parentheses means that we want to select all the elements of the first dimension of our array, and then the number 1 in the second position, the second spot, means that we want just the first element of the second dimension, so exactly the definition of first column. The same will obviously work if you want to select an entire row, but we need to put the column on the second position here. If instead of selecting the entire row, we want just a subset of the second row, like this, we can use this syntax here. So it's 2, column 5. We are basically specifying the first and last column that we want to select. Differently from, unlike Python or other languages, both indexes here, 2 and 5, will be included in the slicing. So we will select element from column 2, 3, 4, and also 5. So there are all the columns will be considered. More than that, operation of indexing and slicing in MATLAB can be directly combined with other operations. Like if we use this syntax here, we can directly sum all the elements on the second row by simply using this command here. Or this other example shows how you can look for the maximum value of the third column. So you can just combine slicing and very simple operation very easily. Okay, so this covers pretty much the very basic of array creation, indexing, manipulation. Then, as I said, MATLAB is really built around the idea of making as easier and intuitive as possible working with multidimensional arrays. So in this slide, I list a lot of basic operations you can do on a vector, which is a one-dimensional array. We are not going to discuss all of them today, but you can use, if you want, this slide as a sort of a cheat sheet later on. I just want to focus your attention on a couple of interesting operations. So let's say we have these 3 arrays. A and B are row vectors, because you can see we use commas to separate the elements, and C is a column vector because of the semicolons, okay? Well, transposing a vector in MATLAB is as simple as using an apostrophe after the name of the vector. As you can see, we started with a row vector, and we get as a result of the transpose operation a column vector. Another interesting syntax choice is when we want to perform element by element operation between arrays of the same shape. Element-wise multiplication, for example, in MATLAB, between two row vectors like A and B, can be performed by simply prepending a dot to the star operator. As a result, we will get another row vector with each element resulting from the element-wise product of the two arrays. So 1 times 4 is 4, 2 times 5 is 10, 3 times 6 is 18. So it's element-wise multiplication. And the same obviously work for element-wise division. If we don't use the dot operator and we just call for a star product, we are implicitly asking MATLAB to perform a dot product between the two vectors. Clearly, a dot product can be done only if the shape of the two arrays is suitable for dot product, just for linear algebra rules. In this case, we are multiplying a 1 by 3 row vector for a 3 by 1 column vector, so we will get, as a result of the dot product, a 1 by 1 scalar value as expected. Okay, working with matrices, a matrix is basically just an n-dimensional array. So this is not more difficult than working with vectors. The interface to basic operation is exactly the same. So we can still use dot operators for element by element operation, the apostrophe for transposition, and this syntax here for matrix multiplication and matrix vector operations. So it's really straightforward, the extension. Moving on from data type and basic operation, as any programming language worth of this name, MATLAB needs tools to control the flow of how the code is executed. So every main type of control flow is available in MATLAB. For instance, we can use an if-else condition if you want to execute a snippet of code, only if a certain condition is met. To do that in MATLAB, we just need to use a if keyword to open the code of the if-else condition, and end keyword to close this section of code. We don't need to use any kind of bracket or special indentation. MATLAB will just look for the opening keyword and the closing keyword, and everything in between we will treat it as an if-else condition. You can also use else and else if in between if you want to check multiple options at once within the same portion of code. Also, for loop is available. Usually a for loop allows you to run a piece of code for a fixed and known number of times. The way to call a for loop in MATLAB is as simple as using the keyword for to open the loop and the keyword end to close it. In between, you will have some code that will be executed multiple times, and you can also nest more than one loop, one inside the other. The last major control flow mechanism is the while loop. Usually you will use a while loop if you want to run some code multiple times, but you don't know in advance how many times you want to repeat that code. So as usual, a while loop will check for a condition and will keep running the code inside of it as long as the condition is met. In MATLAB, as in all other languages, if you want to exit the loop early or you want to check a secondary condition, you can use the break keyword to exit prematurely the while loop. So you pretty much everything you will need to control the flow of your code. So we make it this far, covering as quickly as possible the basic syntax of MATLAB as a programming language. But let's now move a step forward and see a few best practices of how you can actually should write your code. So I said previously that you can use the command window to write your code. The fact that I said that doesn't mean that you should really do it. Command window is great if you want to check values of variables, you want to call a script, you want to debug your code, or many other things, but it's not the best place if you actually want to write some code. Instead, you can click the first button in the toolbar menu up here, which says New Script. Doing this, a new window will pop up, which is the editor window. MATLAB editor is a dedicated text editor in which you can write text that will be saved as an M file, a .m file. An M file, as its core, is nothing more than a text file containing a sequence of MATLAB instruction. This instruction will be executed one after the other, top to bottom. You can run the script by clicking on this button up here, which says run. And running a script will produce the exact same results as if you were to execute each line of the script, copying and pasting it into the command window. The advantage is that you can keep track of what you're doing. You can save your script so that you can maybe reuse it later on a different data set, or just to reproduce your results later. So yeah, it's as easy as it sounds, I hope at least. But this has a cost in terms of security issue, because the problem with scripts in MATLAB is that they don't have a dedicated memory space, and they actually share the same workspace as the command window. This means that if we create a variable a using the console, and then we run a script which redefine a new variable a, we lose the original one, and there is no coming back from that. So being aware of this is more a matter of practice, but it is something that you need to be careful about if you use scripts. If instead you want to have a proper and better control over what your code does and which part of memory it can read and write, you can use a different type of M file, which is a function M file. Writing a function allows you to encapsulate a set of commands within a dedicated space, and then you can give a name to the function, which is basically an alias that you can use to call that set of instruction later on multiple times during your processing. The main difference between a script M file and a function M file is in the first row of the function file. This starts with the keyword function and end with the end closing keyword, as we have already seen that all MATLAB statements that encloses a portion of code need this closing end. Right next to the function keyword, you can list between square brackets the list of output variables. This is the way MATLAB avoid basically to use a proper return statement, that as you will see in any other programming language. So instead of the return statement, you will just list your output up here. And if you want to pass input to the function, you will list them between parentheses right at the extreme right of the first line of code. The body of the function will be used to process the inputs in order to produce the outputs. Then you can give a name to the function, and you will save the M file with the same exact name. Choosing a unique name for your function is important, because that's how then you can call the function so that you can actually use its functionality. In this case, you will pass an array A, and we will get as a result the square of the arrays element-wise. What's good about function is that, unlike script, they have their own memory space, which means that a function does not interfere with the main workspace, so we are safe that the only way running a function will affect unwillingly our code is through, will affect our code is through the output variable that we define when we wrote the function ourselves. Yeah, as a general rule, I will be really quick about this. As a general rule, my suggestion is that every time you need to write some code in MATLAB, you should try to refactor as much code as possible into as small as possible functions. And you write only one big script file, which will act as your main file. From this main file, you can call as many functions as you want or can. They can be your own function, they can be function provided by some toolbox, but you should stick with only one script file and then many function files to be sure and to get an easier debugging of your code. Okay, I said previously that MATLAB editor is mostly a text editor. Probably a better definition of it is that it is a text editor on steroids, as it has a lot of really good functionality that can assist you while you're writing your code. One of the most interesting one is that it continuously performs automatic code checking. It checks everything you're writing, and it keeps giving you suggestions about how you can improve your code, or giving you warning if you have any error in your code. So you may have missed some parentheses, or you may have missed the semicolon at the end of the line. So using this suggestion that the MATLAB editor gives you is as easy as looking to this right sidebar on the editor window. You can click on each one of these orange markers to jump to the line of code they relate to, and then you can read the message that the editor is giving you so that you can try to improve it. Using the editor, then you can also leverage probably one of the easiest way to debug your code live while coding. In MATLAB, doing this is as easy as highlighting the section of your code you want to test, and then press F9. As long as all the variables needed by this snippet of code have already been defined in the workspace, you will immediately see the output pop out on the command window. So you can check for errors. You can just see if the outcome is what you are expecting from the code. If instead you want to choose to opt for a more proper way to debug your code, you can still do this through the MATLAB editors. This is as easy as double-clicking the line number. Doing this will create this red dot, which is a breakpoint. This means that the next time you will execute your code, you will run your script or function, the execution will stop at this point so that you can check if everything is going as expected. You may place as many breakpoints as you want in your code, and while executing, you will see a green arrow like this that will tell you at which breakpoint you are currently stopping. In MATLAB, debugging is quite intuitive because there is no real debug mode. If there are breakpoints in your code, when you run the script, you will stop at each one of them sequentially. And simply, if there are no breakpoints, all the code will be executed. So that's it. You don't really need to decide beforehand if running on debug mode or just testing the entire code. While the standard editor we just talked about is quite cool and full of functionalities, in the latest releases of MATLAB, Mathworks added also a new type of editor, which is called Live Editor, and that you can open by clicking this second button here on the toolbar. The Live Editor shares all the same basic functionality of the standard editor, but it can also combine MATLAB code, like here, with formatted text, LaTeX equation, and images, all in the same place. More than this, it can also store outputs like images or print statement alongside the code that produces it. In this way, you can basically create high-quality report with code and results together in the same file, and you can export this as a PDF file, as an HTML or a LaTeX file. So yeah, just give it a try because it's really cool functionality if you want to share your code with your colleagues or just write the report really easily. This is basically a duplicate of the idea behind Project Jupyter, for those of you who know Python. But yeah, don't tell them I said that. Okay, so another interesting way that MATLAB can be very useful for people working on research and data analysis is because it offers plenty of resources designed for the purpose of data exploration and visualization. The following set of slides I don't want to be an exhaustive list of all the graphic functionality provided by MATLAB because it will be an endless list. But I thought that it could be interesting to provide an overview of the most common ones, just to show you how creating even very complex images is often a matter of calling one or two ad hoc functions. Okay, let's start with the simplest one, which is plotting arrays. So the function plot, you can see here, requires just two main inputs, the independent variable and the dependent variable. And the latter one, the independent variable, can also be a matrix, doesn't need to be a one-dimensional vector. If that's the case, as shown here in this picture, all the rows in the matrix will be plotted on the graph versus the same independent variable down here. After that, you can personalize almost everything. You can change labels, you can change axis name, you can set the title, personalize the legend, change it, color, line width, markers, almost everything. The documentation is your friend in this case. Let's now imagine that we have some data and we want to fit a model to this data. Usually, a result of a fitting will be a continuous curve with some confidence interval. Okay, so you can use the function line, which has the same interface, so dependent variable, as the plot function we saw before. And using this, you can just easily show upper and lower confidence interval together with the fitted curve, which is the black one here. So that's really easy as writing 3 lines of code, 1 for each element of the graph. Something else that can happen is that we want to show 2 sets of data in the same plot, but if we use the same y-axis, one of them will be almost invisible. But in MATLAB, if you want to use 2 different y-axes on the same plot, doing this is just a matter of using this keyword here, y-axis left or y-axis right, and we just need to call this right before the plot instruction, and then MATLAB will take care of assembling this very nice plot here. Clearly, 2-dimensional plots are not the only thing that can be done. We can use, for example, the plot tree function to obtain 3D plot like this. That can be a very nice representation if you're interested in plotting, for example, MR spectra. And obviously, every plotting library worth of this name should give you the full power of assembling your figure as you see fit. In MATLAB, this is as simple as calling the function subplot before any other plotting instruction. The first 2 inputs of subplot are the total number of rows and columns of the subplot grid. And the third one is the index of the position in the grid you want to use for the current plot. The results of this code will be that instead of having 4 different figures, you will have just 1 figure with 4 subplots in it. So that's just, we just need 1 line to assemble these four figures together. You can also look at 3D vector field, for instance, if you want to study the magnetic field across a certain area and to see direction and strength of the magnetic field itself. You can use the quiver function for this. So using the quiver function, we plot all these little arrows here, whose length is based on the strength of the field in that point. And you can also create video or GIF animation out of this quiver plot if you just make the vector field time dependent so that you can show, for example, how the voltage changes across time like this, which is really useful for PowerPoint presentations. If you want to go even fancier, you can be interested in trying surface rendering. For this purpose, MATLAB provides, between other functions like surf or mesh, possible usage of this could be to visualize some brain meshing that may result from some free surface reconstruction, so that's you will just need to provide the list of the mesh coordinate to do that. If instead you want to show images, this is as simple as using the image function. You will use actually image if you want MATLAB to take care of almost everything, or you can use image SC if you want a little more control on the scaling and windowing of the visualization. With both this function here, you will have the possibility to change and experiment with changing color maps, color bar position, windowing, titles, until you find the best representation for your specific goal. But that's just the tip of the iceberg, obviously. How crazy you want to go with complex visualization in MATLAB is totally up to you, your imagination, and clearly the data that you want to show. For example, these visualizations were made all using MATLAB, so The message here is that if you want to display a certain results from your work, rest assured that there is probably a way that you can do it with MATLAB. Okay, great. So I began this presentation saying that I wanted to target an audience of people with almost no computer science background, but so far I've been just talking about writing code, defining variables, functions, script, and so on. So is it true or not that you can use MATLAB even without writing a single line of code? Well, as weird as it may sound, while with all other languages like C++, Python, or even R, to get something done, you need to sit down and speak the same language as the compiler. MATLAB actually has a lot of tools that allow people who don't know how to code, or better, that don't want to code, to enjoy its capabilities and get the job done at the end of the day. Even better than this, you don't need strange workarounds to do that, because a lot of functionalities are already available within MATLAB itself. So let's see what I mean by this. If we look at the menu toolbar, we can find a tab called Apps. In there, you can find a library of MATLAB applications, Matlab APPS, which are self-contained MATLAB programs that allow the user to complete a very simple and limited task just using an ad hoc user interface. If you expand the drop-down menu, you will see a huge list of applications that are ready to be used. Well, at least this is my MATLAB. In your MATLAB, you will see all the applications that come with the toolboxes for which you bought a license, but that's a separate story. To understand what I mean by application and by using MATLAB without coding, let's see a couple of examples of such apps. So one of the most used and always available one is the interactive data import application. Let's say you've done some processing, maybe in Excel or something similar, and you have a CSV file you want to open in MATLAB, maybe to do some visualization and plotting. You can either click the import data button or just drag and drop your file into the command window. Either choice will fire up the interactive import application that will automatically scan your file, trying to guess the best way to read it and show a preview of it. Once you are in this application, you can maybe adjust some import parameter, like you can choose a different column delimiter if the auto detection somehow failed. You can decide the type of workspace variable you want to use to read your file into a MATLAB variable. You can choose a strategy to fill missing data in case you have it. And eventually you can actually import your data. Quite interestingly, you can also save a script or a function for this import that you did. In this way, next time you want to import the same type of file, you can just call this function instead of having to set all the parameters manually again, which is really useful for reproducibility. So let's say now that the imported data are some time series that we want to fit. Well, instead of going through the MATLAB documentation looking for the best way to write a function to fit our data, we could just give a try to the curve fitting app, which is available if you have the curve fitting toolbox, obviously. In this case, fitting a data set time series, for example, it's as simple as selecting from the workspace the independent variable and your noisy time series. Then you will pick a model from a drop-down menu, and depending on the model you choose, you may have to set some additional parameter. Or you can also write your own model if the choice provided by MATLAB is not enough. Once you are done with that, the app will immediately show us the fitted curve and the residual plot down here. On the left panel, you could read all the details about the fitting, so the value of the estimated parameters, the R-square, the fitting error, and so on. So if you like the results you got, you can export the results to your MATLAB workspace for, I don't know, either plotting or other processing. And you can also save a fit object, which you may call later on to fit the same model with the same settings, maybe to another time series, to another data set. And everything, all of this, without writing a single line of code ourselves in MATLAB. Another interesting application is, for example, the DICOM browser, which allows you to scan the header information of all the DICOMs in the current folder, give you a few details about what's in the header and the preview of the images. Once you find the right image, you may want to export it as a matrix to the workspace, or also you may also send the volume to another application, maybe for better visualization. For instance, you may want to send it to the volume viewer app, which in a few seconds will provide you with a 3D rendering, which could be a volume rendering, a surface rendering of your scan. And then here you can play adjusting in light, camera angle, or like windowing, and so on. So just a matter of experimenting. Obviously, there are many more. We won't have time today to dive deeper into that library, but if you want to find a limit to what is offered by MATLAB library, is certainly the fact that they are designed to cover a broader possible range of user and task. So if you're looking for a very specific software for your research field, we may not be lucky enough to find it listed in the built-in applications, but this doesn't mean that we won't find it anywhere. If it is true that MATLAB is a closed source project, it's also true that the academic community behind it is really huge. This results of this that a lot of third-party tools have been developed during the years, over the years, and some of them are almost as good as commercial software on their own. The first place to look for software like this is the Mathworks file exchange platform, where everyone can upload new function, script, application, and so on, and everyone is free to download and use them for their processing. At this point, I thought it could be interesting to see what the neuroscience community has been doing in the last few years in this direction. A little disclaimer before going on, what follows doesn't aim at being an exhaustive list of everything that's available. And second note is that each one of these tools would require more than one day just by itself to be properly presented. So the idea here is just to show you a few virtuous examples so that if you get curious about it, you know that you can look and study and see if it fits the research you're doing. Let's start with EEG-Lab, for example. EEG-Lab is a tool that if you work on EEG and MEG data, you will probably already know. This is built around an interactive user interface that allows you to process EEG and MEG data, and also to build custom script and processing pipelines so that to make it easy to replicate your experiments. EEG-Lab provides you function to study channel location, to compute field maps, perform ICA decomposition, and also guide and group analysis so that the user really need to know not much about statistics itself, because it's really a guided process. Also, EEG-Lab is an open source platform through which researchers can share new methods in the form of plugins. So like SIFT, for example, which is a tool to study causality and connectivity, or VCI Lab, which is focused on the design and analysis of brain-computer interface experiments. So simply put, EEG-Lab, you can think of it as a competitor of our own mini toolbox, which is used to have a MATLAB interface, but that I fear has been now replaced by the success of mini Python, but you can correct me about this point. Another very famous MATLAB-based tool is SPM. This is developed at UCL in London, and it's a suite of many MATLAB programs focused on the analysis of brain imaging, especially functional imaging, with a particular focus on functional imaging like fMRI, PET, SPECT, and MEG. SPM offers, again, a very quite intuitive user interface that guides you through the entire processing pipeline, taking care of almost everything from the pre-processing like image registration and normalization to atlases, to the estimation of a general linear model based on the functional task performed, so to produce a set of estimated parameters that are then presented and shown as statistical maps. Again, this description does not really make justice to the tool, but bear with me with this really quick outline. Then if you had the chance to work with data coming from the Siemens Brain PET scanner in basics, here at the Martinos Center, you have already met probably Masamune, which is a MATLAB tool for PET-MR image reconstruction, maintained and developed by people in the Katana's lab, to which I belong myself. This tool takes care of everything from attenuation, estimation, and correction, motion correction. It clearly performs PET image reconstruction in such a way that the MR and PET images are co-registered in the same space. And it provides you with tools for exporting the final image in many different formats, and also to prepare everything that's required for kinetic modeling when when we are dealing with a dynamic data set. Speaking about kinetic modeling, MIACAT is a software, a MATLAB-based software for the analysis of PET-MR dynamic data, which leverage a quite complex but intuitive MATLAB user interface to provide really point-and-click access to a very complex library of underlying functionalities for PET neuroimaging data processing. The overall pipeline takes care of literally everything from the co-registration of the functional PET to the structural MR data, to the import of blood input data, and everything that lies in between having a time series of PET volumes and producing a set of parametric maps. Okay, that was the last one, but again, this wasn't meant to be an exhaustive list. I just hope I capture your interest by talking about this virtuous example of writing open source tool while using a closed source software like MATLAB. Before closing up this webinar, however, I wanted to dedicate some time to probably 2 or 3 people that, yeah, I'm kind of optimistic here, that may be interested in something a bit more advanced. Let me start with mentioning how we can actually use MATLAB here at the Martinos Center. So if the easiest way, absolutely the easiest way, is to use any of the many Linux machines we have around. If you're logged into any one of them, you can just type MATLAB in a terminal, and the GUI we saw before will just fire up and it will be up and running in no time. When you run the MATLAB command, this executable is linked to the default MATLAB version. What default means is probably, as far as I know, up to the help desk, but it's not necessarily the latest version, always the latest version. However, there are many versions of MATLAB installed in our server, so if you really need a specific version, you can just use the one you want by calling the right executable. Second question is, can you actually use MATLAB from your own laptop instead of a Linux workstation? The answer is both yes and no, because MATLAB, the problem is that it needs a license to run. So one thing you can do is to apply for a network license. You can follow this link for more information. The problem with network license is that this means that you will be able to use MATLAB only while connected to a partner's network. This could be either Ethernet connection, Wi-Fi connection, or VPN. But if you are outside of the network, you cannot start MATLAB. Another option, from my point of view, the easiest one, is to use your laptop to remotely access one of the Martinos machines, and then you will use MATLAB from inside these machines. So these 2 links will give you instruction on how you can do this with 2 different software. It's just a matter of your personal taste, which one to use. Ultimately, the only way to actually have MATLAB with you all the time, also at home or while on train, on a plane, is to buy the standalone license. So this will come with the cost of buying license and toolboxes. So you can just contact people at Mathworks for this. Apart from that, we need to keep in mind that Martinos Center has only a finite number of MATLAB licenses and toolboxes, and once they are all being used by people here in the center, the only thing you can do is to wait for a license to free up. You can also, you can use MATLAB also on the on our cluster, which is Launchpad. But yeah, this link, you will have all the information you will need to understand how you can actually use the launchpad cluster for MATLAB jobs. Let me just point out that MATLAB jobs need to be submitted to a dedicated queue, which is called MATLAB, which will check also the number of licenses that are available, and if you're allowed to access all those that your code require. The way to prepare your code to work on the cluster is the same as you would do with any Bash or Python script. You need to package all your MATLAB code in a script that could be executed directly from the command line without requiring any kind of interaction by the user. You also have the option to actually deploy your MATLAB program into an executable, which is kind of an even higher level than that I wanted to talk about today. But if you're interested in doing this, at this link you will find detailed explanation and also example of how you can do this. Speaking of running MATLAB script from command line, which is what is required to submitting job to Launchpad, let's see when this can be actually useful for you. Let's say that you have a nice Bash script that you may have written yourself or some lab mate have been building during the years. This script does a lot of things like calling FSL instruction, free cipher reconstruction, and so on. Let's say that for some reason, midway through the execution of this script, you want to do some processing in MATLAB. So instead of stopping the Bash script, opening up MATLAB, running manually a script maybe to produce some image or whatever you may need to do, you can put a UNIX command like this one directly into your script. Using this command, you are basically asking to run this script, which is my script, passing the full path, but without firing up MATLAB desktop interface. So this option, no desktop, no display, means that you are executing this MATLAB script using MATLAB, but without opening up the user interface. So if you do this, once MATLAB is done executing your script, your original Bash script can just proceed with the next instruction, maybe going back to another FSL command or whatever, saving files, moving files from different computers and so on, without requiring any kind of interaction from your side. And what if you want to do the opposite? You want to call some other function or command line tool while running a MATLAB script. Can you do this? Well, if you're interested in interacting with Python, maybe you have some library or toolbox in Python that you want to use, you are particularly lucky because MATLAB in the most recent edition integrates a Python subsystem that you can use to execute Python code natively. Let's say that you have this very simple Python model you want to call from MATLAB. If you want to do that in your main MATLAB code, you can just import your model by calling this py.importlib, import model. By doing this, mymod.py is added to your Python path, and you can call any function defined into it by using this syntax, py.modulename.name of the function. So that's as easy as it gets, I guess, because that's a new functionality in which MATLAB is really able to talk with a Python subsystem. As a result, the values that are returned from the execution of this Python function will be immediately stored as MATLAB variables into MATLAB workspace. So you have a direct connection between Python workspace and MATLAB workspace. So now it's really straightforward what you can do. But if you are not interested in running just Python code and you want, for instance, to run an FSL command in the middle of a MATLAB script, what you can do is, given that you don't have clearly a dedicated subroutine to run FSL in MATLAB, what you can do is to use a direct system call. The system command basically provides MATLAB with a direct interface to the command line. So simply put, all you need to do is to define a MATLAB string, in which you write the command you want to run exactly in the same way you will type it in a terminal window. And then you can pass this string to the system command as an input to the system function. Doing this, you are basically passing all this command to the UNIX subsystem that will execute the command. Unlike the specific Python subsystem, in this case, you don't have a direct connection between the results that you get from this FSL command and your MATLAB workspace. So you will need, you are forced to read and write results to the disk so that to make MATLAB able to talk and exchange data with other binaries that are called using the system function. The last topic I'm going to touch is probably one of the biggest problems that sometimes scares computer scientists away from MATLAB, which is the execution speed. MATLAB code, especially the code written by the average user like myself, is almost always painfully slow. This topic will require an entire hour by itself, so we'll just give you a few hints, like good practices. If something catches your attention, you can go deeper and see how you can do it properly. So the first thing you will always want to do is to try to use function instead of scripts, both because of the security issues we said before, but also because the first time you call a function, the interpreter performs a sort of compilation. And this means that the next time you will call the function, the execution will be a little bit faster. Then you will want to pre-allocate arrays. Let's say that you have a for loop and you are saving the results of execution inside a big multidimensional array. If you pre-allocate the final size of this array, the execution of this for loop will be much faster than you keep expanding the array iteration after iteration. In general, then you will want to avoid the use of for loops as much as possible because MATLAB is really, really bad at handling them. And for the same reason, you would want to try to keep the body of a for loop as short as possible, doing as many operations as possible outside of it. Finally, do not ever change the working directory or modifying your path during an execution of some script, because every time you do that, your code will be recompiled and this will have a huge impact on your performance. If you're actually forced to deal with big for loops, maybe because you are replicating your processing through many subjects, MATLAB offers you a very nice way to speed up your code by leveraging parallel execution, given that you have access to a parallel computing toolbox. Doing this in MATLAB is as easy as changing a keyword from for to par4. The speed up factor here will clearly depend on what your for loop is doing and the number of cores available on your machine, but you can trust me, or you can try yourself, that you will always see a difference, even for the most simple instructions. The problem with par4 is that you cannot always use them. Usually, you cannot just simply switch every for with a par4. You usually can use a par4 loop only if you have many iterations of very simple calculation, and above all, if you need that every iteration of your for loop has to be independent from the previous one. If one iteration depends on the results of the previous one, you cannot clearly parallelize your problem, so you cannot use par4 loop. Then you don't want to use par4 if you plan to submit your code to launchpad during the cluster. Sometimes because it's often useless because the cluster is already designed to parallelize your execution, but also because you will risk to break your license number limit because you will ask for too many MATLAB licenses to run. And then you cannot use parallel toolbox par4 if you don't have a license available for the parallel toolbox, clearly. Okay, so that was it. I hope I've been able to, we cover a lot of topics. I hope that I've been able to give an overview of the basics of what you can do writing some code without writing some code, and at least you are a little bit more interested in giving it a try and see if you can do something useful for your research using MATLAB. If you have any questions, I don't know if we have it right now, or you can just reach out to me. Contacts down there. Thank you very much.